So today I'd like to prove the addition property of the complex conjugate, which is the conjugate of z1 plus z2 equals z1 conjugate plus z2 conjugate, where z1 is the complex number a plus bi, and z2 is the complex number c plus di. And just as a reminder, the complex conjugate of a complex number, a plus bi, is a minus bi, so you keep the real part the same, but invert the sign before the imaginary part, which basically means that you multiply the imaginary part by -1. So this means the complex conjugate of c plus di is c minus di. So here's how we do the proof. We start with z1 plus z2 under the conjugate, and this turns out to be a plus bi plus c plus di under the conjugate if we plug in the definitions for z1 and z2. If we group up the real and imaginary terms, we can rewrite this as a plus c plus parentheses b plus d multiplied by I, all under the conjugate. And this is just equal to a plus c minus parentheses b plus d times I, since the imaginary part of the third expression is b plus d. So to find its conjugate, we need to keep the real part the same, so it's still a plus c in the fourth expression, but multiply the imaginary part by -1. So the imaginary part of b plus d becomes negative parentheses b plus d in the fourth expression. If we distribute, we can rewrite the expression as a plus c minus bi minus di, and we can reorder the terms and group them up to rewrite the expression as parentheses a minus bi plus parentheses c minus di. And you'll notice that a minus bi is just z1 conjugate, which we defined earlier, and c minus di is just the expression for z2 conjugate. So a minus bi plus c minus di is just z1 conjugate plus z2 conjugate. And we started with z1 plus z2 under the conjugate, and worked out that this equals z1 conjugate plus z2 conjugate. This means the conjugate of z1 plus z2 equals z1 conjugate plus z2 conjugate, which is what we were trying to prove. So as you can see, the proof is actually not that hard, and it mostly involves using the definitions of the complex number and the complex conjugate, and just doing some algebra and rearrangement of terms.